Unit 4. Perturbation theory. Perturbation theory. Hello students, it is clear? Is it clear, the screen?
Yes, ma'am. Yes, ma'am.
Okay. So what is the meaning of perturbation? Perturbation means some sort of disturbance. Okay. It is nothing but some sort of disturbance. Disturbance. Okay, students. So this is the meaning of perturbation. And the perturbation theory is a set of approximation schemes directly related to the mathematical perturbation for describing a complicated quantum system. Okay, students, actually, we already learned about the Hamiltonian, no? You know what is the meaning of Hamiltonian? It is energy. Okay. So if we calculate the energy of any particle, okay, so there is not any, the particle is not at the rest position. Some sort of disturbance is always there. If we talk about atoms, okay, so they always, the electrons get exciting and go to the next higher energy level state, then again can come back to lower energy state. Okay, na, so this is nothing but one some sort of disturbances, no? So we have to calculate here the disturbance energy also. Okay, na, it means that the total Hamiltonian. So the total Hamiltonian H, it is nothing but energy. So it is consist of two terms. One is H naught and second one is H prime. Okay. So this is total Hamiltonian, where H naught is what? H naught is correspond to unperturbed Hamiltonian. It is unperturbed Hamiltonian. Okay, and H prime is what? H prime is perturbed Hamiltonian. Okay, perturbed and unperturbed means this term denoted the disturbance. Okay, and this term is simple term, not any disturbance is here. Okay, so the perturbation theory has two types. Perturbation theory has two types. One is time independent perturbation theory. Time independent perturbation theory. Second one is time dependent perturbation theory. Okay, students. Now, time independent perturbation theory has again two types. One is non-degenerate system perturbation theory for non-degenerate system. You know what is the meaning of non-degenerate? Okay, degenerate and non-degenerate system you already learned, but I am again telling you that non-degenerate system means there is only one eigenfunction. Uh, okay, eigenvalue correspond to eigenfunction. There is only one eigenvalue corresponding to eigenfunction. Okay, it is non-degenerate. The meaning of this is non-degenerate. And other one is for perturbation theory, time independent perturbation theory for degenerate. Degenerate system. Okay. Now you know that what is the meaning of degenerate and non-degenerate. Huh? So, uh, yeah, I already told you, na, correspond to energy level, eigenvalue, there is only one wave function. There is only one wave function. So the system is known as non-degenerate, only one wave function. Like I am giving to example that I already give example of in operator system. Okay, na? What is suppose d by dx one operator? If we apply this operator on e by 3x, okay, then what is that differentiation of e by 3x? 3e by 3x. Okay, now. So there is not any change in function, but eigenvalue is there. So only one eigenfunction for any eigenvalue. So the at that time the system is called non-degenerate. Okay, and continuously if the values are changed, eigenvalues are changing, so eigenfunctions are also changing. So at that time the function is degenerate system. Okay, now let's start the derivation of this theory. So let's start with the Schrodinger wave equation. If we want to know any property of any tiny particle, so first we start with Schrodinger wave equation, which is H psi is equal to E psi. Okay, na Schrodinger wave equation H psi is equal to E psi. But here we are taking W psi. Okay. Then one state is there which is K. So W K psi K. Okay, student. So what is the meaning of W here? W is eigenvalue and this psi is eigenfunction. Okay, and this H is represents operator. This H is denoted operator. So this is equation 1, student. H represent the operator. So H is equal to what? You know all the value of that Hamiltonian which is from Schrodinger wave equation. It is H cross square by 2m del square plus VR. Okay. So now total energy Hamiltonian of perturbed system. This is so total. How can we return? How can we write this total energy Hamiltonian? It is in the form of one series, which is H is equal to H naught plus lambda H prime plus lambda square H double prime plus and so on. It is equation 2. Okay. What is H naught is here? H naught is unperturbed Hamiltonian. H naught is unperturbed Hamiltonian. Okay, then H prime, H double prime, and so on. These all are perturbed Hamiltonian. Okay, so don't be confused, students. What we are doing here? We are uh, just already learned in our first unit that for any if we want to know the properties of any tiny particle, the position and momentum, all these things, so what we do, we take Schrodinger wave equation. Okay, and Schrodinger wave equation we solve. So for unperturbed Hamiltonian, Schrodinger wave equation can solve easily without any problem, but for perturbed Hamiltonian we cannot solve Schrodinger wave equation. Okay, students. So there are some constants and we have to solve the constant values. So the energy eigenvalue of total Hamiltonian for perturbed system. Okay. So in terms of lambda, what we are doing here, that again like Hamiltonian we are writing here, no? So eigenvalue omega, sorry, WK, also we can write WK naught plus W lambda WK prime plus lambda square WK double prime plus and so on. It is equation 3. Okay. Now for corresponding eigenfunction. This is eigenvalue now. This is Hamiltonian. This is eigenvalue. Now eigenfunction. What is eigenfunction? Psi k. Psi k. Okay. So again we can write that psi k in the form of this series. Psi k naught plus lambda psi k prime plus lambda square psi k double prime plus and so on. This is equation 4. Okay, student. Now substitute these values, means h value, wk value and psi k value in equation 1. What is our equation 1? It is h psi is equal to wk psi. Okay. So put first value of h. What is that? H naught plus lambda h prime plus lambda square h double prime plus and so on into psi value. Psi k naught plus lambda psi k prime plus lambda square psi k double prime plus and so on. Okay, is equal to what? Wk psi k, no? So wk value wk naught plus lambda wk prime plus lambda square wk double prime plus and so on into psi k value again. Psi k naught plus lambda psi k prime plus lambda square psi k double prime plus and so on. Okay, students. So we write. Now what we will do, equating the terms without containing lambda. Okay. So first we equate that h naught psi k naught terms, then h prime psi k prime term, then h double prime psi k double prime term. Okay, students. So first equating that h naught. So here h naught and psi k naught is there, no? So h naught psi k naught is equal to here wk naught into psi k naught. Now this is first term which we equated. Okay. So this is equation 5, no? This is 6. Now this prime term we have to equate. Okay. So first lambda term we are equating, then lambda square term we will equate. Okay. So lambda term is lambda h prime. Here lambda uh, we have to multiply first, no? We have to multiply first. So what we will do, h dash psi k naught, h dash psi k naught, then plus h naught psi k dash. These two terms we are taking, no? So we have to multiply both the terms. So first h prime psi k naught plus h naught psi k prime is equal to, here also same, wk naught psi k prime plus wk prime psi k naught. Okay. So here k term is showing one state, same state. Okay. Now what we are doing, we psi k prime values one side and psi k naught values one side we are putting. So h prime psi k naught taking this side, so minus wk this term. Okay. Yeah. Minus wk, 1 minute. First we are taking this, no? So first h naught psi k prime minus wk naught psi k prime is equal to, now this. So first write wk prime psi k naught, this term this side, so minus h prime psi k naught. Now h naught minus wk naught psi k prime common is equal to, here psi k naught common, so wk prime minus h prime into psi k naught. This is equation 7. Okay. Now here lambda, we already equated lambda. Now equating the term lambda square. Okay. So lambda square, for this what we will do for equating lambda square. Okay. It is h double prime psi k naught. See here, h double prime. Okay, h double prime psi k naught. Then h double prime this term, then h double prime this term. Okay, student. So we are equating here for lambda square value. So three values we have to write. H double prime psi k naught plus h prime psi k prime plus h naught psi k double prime is equal. There also three terms, wk naught psi k double prime plus wk double prime psi k naught plus wk prime psi k prime. Now same term, double prime one side. Okay, like this. So always we have to common psi term. Okay now. So here I am writing direct equation h naught minus, see here h naught and psi k double prime. Here omega sorry wk naught psi k double prime. So both these term we will take psi k double prime common. So h naught, this term comes this side. So it is minus wk naught psi k double prime. So these two terms over. Okay student. Now plus, now which term, psi k prime. So this is psi k prime. So here h prime, this one wk prime. So minus wk prime psi k prime. Now third term, which is this psi k naught. So plus h double prime minus wk double prime. It is psi k naught. We common psi k naught. Okay, student. So this is equation 8. We equating. Okay, we already equated that lambda terms. First, without lambda term, which is h naught psi k naught is equal to wk naught psi k naught. Second one, lambda equating term, which is this, and third one, lambda square equating term. So three equations we got. Okay, three equations we got. Now equation 6, 7, 8 represent what? Unperturbed first order, second order perturbation. Okay, first equation 6. Equation 6, there is not lambda. Okay, there is not lambda. So this term means h naught psi k naught is equal to lambda wk naught psi k naught. This is denoted unperturbed. Perturbed. Unperturbed term means there is not any change in energy. There is not any agitation in electrons. The atom is unperturbed. There is not any change. Okay. Then first order equation 7. What is equation 7? It is h naught minus wk naught psi k dash is equal to wk prime h prime. We can say dash or prime, anything. Okay, both are same. This is first order perturbed term. Okay. Now then equation 8. Here it is. This term. Okay. This term second order perturbed term. Okay.